Optical isomerism. It is the second type of configurational isomerism. First, let us see what is plane polarized light. Plane polarized light is the light produced when this ordinary light is passed through the Nicol prism. Okay, light produced when ordinary light is passed through Nicol prism. Okay. So when the ordinary light is passed through the Nicol prism, this polarized light will will vibrate only in the one direction of the plane. Okay, such a light is known as plane polarized light. Okay. Now, when solution of certain compounds is placed in the path of the plane polarized light, this light will rotate either in the left or in the right. Okay. This process is known as optical activity. Optical activity. That means when solution of certain compounds is placed in the path of plane polarized light, it will rotate either in the left or right. This process is known as optical activity. Okay. Left or right. Okay. And this phenomena is known as optical isomerism. Now let us explain this rotation. Okay. Left and right rotation. Okay. First, when the light rotates in left is called levorotatory. When light rotates left, the compound is levorotatory, or the compound is L form or minus isomer. Okay. And when the light rotates right, the compound is dextrorotatory. Okay, or D form, or it is the positive isomer. Okay, so there must be negative and positive isomers are there, and these positive and negative isomers are optically active in the compound. Okay, now next let us discuss about molecular asymmetry and chirality. What do you mean by molecular asymmetry and chirality? In the case of these optically active compounds like plus and minus form, they are not superimposable to the mirror images. Okay, optically active compounds, active compounds are, that is plus form and minus form, not superimposable to their mirror images. Superimposable to their mirror images. Such compounds are called chiral compounds, and the property is called as chirality. Okay, mirror images. Compounds is images, that compounds are called as chiral compounds. and the property is known as chirality. Okay. And in the case of optically active compounds, there must be an asymmetric carbon. Okay, that is, asymmetric carbon means carbon contains, their four substituents are different. Such carbon atoms are called as asymmetric carbon. Take one example, 2-butanol. 2-butanol. Okay. OH. Okay. CH3. CH2, CH3. Okay. Consider this compound. And in this case, we can see that so hydrogen is here. O. Okay. In this case, OH, the compound is rotating in the clockwise direction and the compound is plus form and its mirror image. CH3 will be here. Okay. Hydrogen here. CH2, CH3. In this case, we can see that OH, CH2, CH. This will rotate in the anti-clockwise direction and it is minus form. Okay. So these are the two mirror images and they contain asymmetric carbon. It is denoted by an asterisk sign. Okay. So these molecules are asymmetric. So molecular asymmetry means these compounds containing asymmetric carbon. So if molecular asymmetry is there, such compounds are optically active compounds, or that compounds are also called as chiral compounds. Okay. This much about the molecular asymmetry. Now, next topic is enantiomers or enantiomers. Enantiomers. What do you mean by enantiomers? Or enantiomorphs. Same like this is optically active compound. These non-superimposable optically active compounds are also called as enantiomers. So enantiomers are stereoisomers which are non-superimposable images and they rotate plane polarized light. Okay. They are stereoisomers. Okay. They are stereoisomers which are non-superimposable. Okay. To their mirror images, to one another. They are non-superimposable to one another and they rotate the plane plane polarized light. Okay. Such compounds are known as enantiomers or enantiomorphs. So all optically active compounds are chiral molecules and these chiral molecules are called as the enantiomers. Example, plus and minus chloro 2-chlorobutane. Okay. 2-chlorobutane. This is an example. Okay. Now, next one is, what do you mean by racemic mixture? Racemic mixture is the equimolecular mixture of enantiomers. Okay. Racemic mixture. Racemic mixture is equimolecular mixture of enantiomers. Okay. Compound contains, if the molecule contains, so we know that these compounds are optically active if they are in the equal concentration. If they are in the 50:50 concentration in the mixture, these compounds are said to be racemic mixture. And also what will happen is, if they are in the ratio 50:50, we can see that they are in the opposite direction. So they will cancel each other. Okay. They are in the opposite direction, so cancelled each other and they become optically inactive. Optically inactive. Okay. Such mixtures are known as racemic mixtures. Okay. Racemic mixtures. And this process of converting the compound into a racemic mixture is known as the racemization. And this racemization can be done by heating with the help of light or some chemical reagents. By heat, light or chemical reagents. Okay. So optically active compounds can be converted into racemic mixture with the help of heat, light or chemical reagents. Okay. Now next is retention. Retentions mean retain its configuration. Okay. Retention means, what do you mean by retention? It's the preservation of the integrity of the spatial arrangement of asymmetric center. Okay. It is the preservation of, that is its integrity is preserved. Preservation of integrity of spatial arrangement of asymmetric carbon. Okay. Asymmetric center even after reaction. Okay. Center even after reaction. Okay. So even after the reaction taking place, the compound retain its configuration. This process is known as retention. And next is inversion. What is inversion? Reverse will be the case. Okay. If the relative configuration of the product will be opposite to that of the reactant after the reaction. If the relative configuration of the product, is retained as in the reactant even after the reaction. Okay. This process is known as inversion. Okay. Or we can say that the molecule is inverted. Okay. Now let us see one example. Take a compound. Hydrogen here and the leaving group is here. Okay. After reaction, this X gets converted into Y. So after reaction, if the configuration remains the same, okay, this gets converted into Y, but the configuration remains the same. Such molecules are, this process is known as retention. Okay. Even after the reaction, the configuration does not change. Next. After the reaction, the configuration of the compound, the inverted. Okay. Why? CH3. Okay. The compound gets inverted. This is B. Okay. This process is known as inversion. Okay. If A and B gets converted into the ratio 50:50. Okay. If it is 50:50 in the mixture, such compounds are known as racemic compounds, or the mixture is racemic mixture and the process is racemization. Okay. Now there is this stereochemical effect in SN1 and SN2 reaction. This can be seen in the case of SN1 and SN2 reaction. Okay. In the case of SN1 reaction, that is a unimolecular reaction, we know that it takes place through the intermediate formation of the carbocation. Okay, so in such cases what will happen is the reagent can attack in both the direction. Okay, so in such cases retention and inversion takes place. They are in the ratio 50:50. So in the case of SN1, racemization takes place. Okay, racemization. Both are in the ratio 50:50. Okay, because the carbocation formation, the reagent can attack in both the directions. So racemization takes place. Whereas in the case of SN2, we know that reaction takes place through the transition state. So the attacking will be only opposite to that of the leaving group. Okay, so in such cases, inversion of the reaction takes place. Okay, inversion of the product takes place. Okay, this much about optical isomerism.